All right, so again, 4 is completing the square with conics. So we have completed the square a couple of times this year, okay? And obviously we worked on conics. This section combines the two together. So when you start to see these equations, they won't look like they are parabolas, ellipses, and hyperbolas, but we will then complete the square to get them into that standard form, and then it will be one of those conics, and from there you'll do the stuff we've been doing. So as a refresher on complete the square, your goal is to keep the ax squared and the bx term on one side of the equation, and then move the other stuff to the other side. So there should be a constant. There might be more than one variable. If there's a number attached to the squared term, we have to take it out. So we divide by it. And then we find what number we're going to fill in by taking the second term, dividing it by 2, and squaring it. We add that term to the left and the right side of the equation to keep it balanced. And if something was factored out, we multiply it by that number before adding it to the right. And then we are going to factor the perfect squared trinomial, and what will result is one of your conics. If there's only one variable squared, then we only have to do that once, and that would be a parabola. If there are 2 variables squared, then we're going to do this process twice for the x and for the y, and then you'll end up with either an ellipse or a hyperbola. So I promise it's not that bad. It's stuff we've done before. We're just putting 2 topics together. All right, so look at number 1. So the first thing you want to do is see what variables are squared, right? What variable is squared here? Just the y. So already I know this is a parabola, because if there's only one term squared, it has to be a parabola. So then I want to figure out by whichever one is squared, that's the one we're going to complete the square for. So the y is the one that's squared. I'm going to bump the 3 to the other side with the x. So just the y's are on the side by themselves. Y squared minus 6y. I'm going to leave that space because that's what I'm going to fill in. And then I'm going to set it equal to x minus 3. So I would have subtracted 3 from either side of the equal sign. Now I've got to complete the square. So I take that 6, I divide it by 2, that's 3. I square it, that's 9. And that's what I'm going to add to both sides of the equation so that I balance my equation out. So what you do to one side, you have to do to the other. On the left, we've now made this a perfect square trinomial. So we factor the first term. Sorry, we square root the first term. Y squared, square rooted would be y. We square root the last term. 9 squared would be 3. We take the sign from the middle term, minus, put it in parentheses and square it. And then we simplify the other side. X minus 3 plus 9 would be x plus 6. With me so far? So we're not doing it just yet, but eventually that will then turn into, this is a parabola, find your vertex, find your focus, and find your directrix. So all the things we already were doing with our parabola, you would then do from here. So there's going to be times when it just says complete the square to get the conic in standard form and you'd be done, like this one. And then there's going to be times in which from here we would then have to do all the things depending on which conic it is. Okay, not so bad, right? So parabola is only one time, but when you get to the okay, so let's say that we now know this is a parabola, and I know that because there's only one term squared, then I would want to be able to identify all the parts of the parabola. So which way is this parabola facing? What variable is squared? Y, which tells you it either goes to the right or to the left, right? Where's 4p? The 4p is what's on the front of the term that's not squared. So what's 4p here? Positive 1. So if it's a y squared and the 4p is positive, which direction is this parabola facing? To the right. What's the vertex? So normally we see it, and these are in parentheses, which that's no different. I just put parentheses around it. What's the vertex of this parabola? -6, +3, right? What follows the opposite of what follows the x, and then opposite of what follows the y. And if 4p is 1, then p is 1/4. So if I was to graph this, yep. The P is the distance between the vertex and the directrix and the vertex and the focus. The P is the distance from the vertex to the directrix and the vertex to the focus. So when I plot the vertex, which is negative 6, 3, I'm going to point my parabola to the right, and I know that because it's a y-squared with a positive 4p. The focus is 1/4 to the right, which would be negative 5 and 3/4 and 3. So I did negative 6, and then I added the 1/4 to it because I'm going to the right. And then that's the focus. And then the directrix is 1/4 to the left. It's a vertical line, so it's an x equals, and it would be negative 6 minus 1/4 because you're moving to the left, so it'd be negative 6 and 1/4. So the first part is getting it into standard form, and then the second part is once it's in there, figuring out all the information you need to figure out based on what kind of conic you've got. It could happen twice. So in example 2, which variable are squared? X squared and y squared. So I am keeping everything with the variable on the left. I'm bumping the constant to the other side. But I want to group them together. So I'm going to group together the x's, and I'm going to group together the y's. So it looks a little bit like this. I'm going to put x squared plus 6x. And then I'm going to leave my space because I'm going to complete that square. And then plus, because there's a plus on that 4, so plus, and I'm going to group together the 4y squared, the negative 8y. I'm going to leave that space. And I'm going to bump the 9 to the other side. So this is going to equal negative 9. Now we complete the square, not once, but twice. First parentheses, not so bad. I just take the 6, divide it by 2, and square it. So 6 divided by 2 is 3. 3 squared is 9. I add the 9 here. And I also have to add the 9 to the other side of the equal sign. I don't have to do it to the other parentheses, because as long as I do it one time on either side of the equal sign, that's balanced. But I do have to do it to the other side of the equal sign. So that first one is not so bad. I can actually keep going with that. Square root the first term, square root the last term, take the sign from the middle, put it in the parentheses, and square it. And that part is done. With the second one, what do I have to do before I can find that third term? Take out the 4. So this is where the yuck comes into play, right? This would be 4, parentheses, y squared. The 4 has to be divided into the negative 8 too. So y squared minus 2y, still leaving that space. Now I take the 2, divide it by 2, and square it. 2 divided by 2 is 1. 1 squared is 1. I'm adding the 1 inside the parentheses. But because we took something out, before I combine it with the other side of the equal sign, I have to multiply that 4 by it. So I'm adding 4. So again, if you take something out of the parentheses, then before I add to balance the other side of the equation, I have to multiply that third term by what's on the front, and then add it to the other side. So this is plus, there's a 4 on the front, the square root of the y squared, which is y, the square root of the 1, which is 1, the sign from the negative 2, which is minus, in parentheses and squared. I'm just going to rewrite it down here so it's neater. And it equals negative 9 plus 9 plus 4, which is 4. So we did the complete the square part, but is this a conic in standard form? No, what do I have to get it to do in order for it to be standard form? Has to equal 1. So the last thing I'm going to do to get it into standard form is divide everything by 4. You don't need the 1 in the denominator, but that is a reminder that there would be a 1 there. So now tell me what you know about this conic by looking at it now that it's in standard form. What is it? It's an ellipse. What kind of ellipse? How do I know it's horizontal? Good. The base on the x, or the denominator on the x squared, is bigger. And that denominator is my a. So a squared is 4, making a 2. B squared is 1, making b 1. And my center is negative 3, 1. Good. So, it didn't obviously tell us that we had to do that this time. There are going to be times when it's going to ask you to do that, and then there's going to be times when it just says get it in a standard form and you're done. Questions? Yeah. So now let's say we wanted to graph this ellipse. I would have a center at negative 3, 1. It's horizontal, so I go right and left the A, which is 2. And up and down the B, which is 1. And then I draw my oval. I didn't ask for it, but if it did say what's the foci, we'd have to find C. And remember, with an ellipse, C squared equals A squared minus B squared. I'd figure out what C is, and I'd add and subtract it from the x coordinate of my center.
What other points did you put in the graph? You just put center?
I did the center, and then I did right and left 2. That's the A, and I went up and down B. You're welcome.
Wait, is A always going to be right?
If it's horizontal. If it was vertical, so if the A is under the Y, then I go up and down the A. So whichever one's bigger. Yeah. All right, last one for today. How many variables are squared? 2. So I'm going to just group, rearrange, and bump the constant to the other side. So 4x squared plus 8x is going to go together. I'm going to leave this space because I'm going to fill that in. This time there's a minus on the 3. What does that tell you from the very beginning? This is what kind of conic? Hyperbola, okay? So be careful when you group that 3. You could put a plus here if you want to start your parentheses, but the negative is only on the 3y squared. And there's no other y, which means I don't even have to complete the square for that y. I will, obviously, if there was another term, when I divide, I'd have to divide by a negative 3. So that's when it will change the sign on the other one. Because there's only one term, I really don't need any of that because I don't need to complete the square. I could just leave it like that. And then the 16 goes to the other side, so it's negative 16. So lucky us, we only have to complete the square that one time. There is something on the front of the x squared, so we got to take the 4 out. 4 goes on the front. X squared plus 2x, leave that space, minus 3y squared equals negative 16. Take the 2, divide it by 2, that's 1. Square it, that's 1. I add the 1 inside the parentheses. I would normally add it to the negative 16, but before I do that, I have to multiply it by the 4, which means I'm adding 4. Still with me? Okay, 4's on the front. Square root the x squared, square root the 1, take the sign from the middle, put it in parentheses and square it. Minus 3y squared equals negative 12. And last step, Divide everything by negative 12. And I get negative x plus 1 squared over 3. That negative could be in the bottom or out front. It doesn't matter, but the sign definitely needs to change. Plus 3 goes into 12, so y squared over 4 equals 1. Now, do you normally lead with a negative? No, so what would you do with that? Good, just switch them. So y squared over 4 minus x plus 1 squared over 3 equals 1. Yeah.
Why is the 3y out of the parentheses?
Because it's the only y term. If there was a y squared and a y, we would group those together, complete the square for the y. But there was no y to the first term, so you don't have to complete the square for it. So tell me what you know about this hyperbola. It's vertical because the y comes first. Vertical. What's the center? Negative 1, 0. What's the a squared? 4. Remember, always first. So a is 2 and b squared is 3. So b is the square root of 3. So if I was making my little box, I'd plot my negative 1, 0. Oops, not there. I'd plot my negative 1, 0 there. I'd go up and down 2. Right and left square root 3, which is like a 1.7 or 1.5. Make my box. Find the corners. And draw your branches. Yeah. So when you take a number on the front, whatever you add here, normally you add to this side, but you have to multiply it by the number that's on the front first. So instead of adding 1, we add 4. Yeah.
That number in the front, does it always end up getting, like, dividing by a number? Or could it be
Only because, oh, yes, usually, I mean, are there times in which there's nothing in the bottom? Like if it was equal to 1, then that 4 would go to the bottom as like a fourth. That's what happens there. I don't think it happens in the homework. I'll check.
Would it affect the graph though?
It would just make your a squared 1/4. So if there's something in the top but there's nothing in the bottom, like if it said 4x plus 1 squared, and then it was like minus, I don't know why, minus 3 squared over 4 equals 1, let's say, if it already equals 1, then this actually goes to the bottom as its reciprocal. And that's what that a squared is. Yeah, so if you see something in the top that doesn't cancel into the denominator, that's what it would look like. So your a would be like a half. Again, I don't think it happens in tonight's homework, but like if it did happen, that's what it would be like. Yeah.
Can you show us the asymptote for this one?
Like the equation? Yeah, so because it's vertical, it's a y minus k, or not y equals k plus and minus a over b x minus h. So it's y equals, there is no k, it would be 0. So you can make it 0 if you want, but you don't need it. Plus and minus, a would be 2 over square root 3. X minus the negative 1 becomes plus 1. That's so hard to read. So y equals plus and minus, I'd have to rationalize that. 2 root 3 over 3, x plus 1 is what it would look like after it's simplified. Which I obviously would strongly recommend using the box because that box is way easier to graph than that. Yeah.
If we had questions on previous homeworks,
Tomorrow we're going to get to review, like I know we're a little rushed today, especially because math ran long, but tomorrow we're going to get to review. I'll go over the conic worksheet because obviously that's not something you can check on WebAssign. And then this is it. Like we're done with content until your test, which is Wednesday. So Friday review, Monday review, Tuesday review. Yeah. All right, so what's squared this time? Just the x, which tells you what kind of conic is it. It's a parabola. And if it's an x squared, we even know it either has to point which way or which way. Up or down. So that you already know. You don't know if it's up or down yet, but you know it has to be one of those, okay? All right, so I'm going to group together the x squared and the 10x, and I'm going to bump the other two to the other side. So minus y and positive 21. Now we could have totally moved the x squared and the x to the other side and it would have kept it positive. I wouldn't have to take anything out when I do my complete the square. But all the visual things that we've learned about in parabolas, we keep the squared term on the left. So I would just say be careful. Don't switch where the 4p would be located. So normally in standard form, the x is squared and the 4p is on the right. All right, so now I'm going to take out the x, or take out the negative. This becomes x squared minus 10x, leaving the space for what's to fill. Now I take 10, I divide it by 2, and I square it. That's 5 squared, which is 25. And I'm adding it here. So normally I'd add the 25 here and here, but I have to multiply by a negative 1 first, which means I am now subtracting 25. Now I factor the left side, so square root the first, square root the last, take the sign from the middle, put it in parentheses and square it, and that would equal negative y minus 4. Yes, sure. Now the rule on standard form of a parabola is that nothing can be in front of the squared term. If there was a number there, we would divide both sides by it. If there's a negative there, we got to get rid of it. So we can either divide or multiply, it doesn't matter which one, by a negative 1, but we have to get rid of that negative things twice. The negative 1 obviously gets rid of this one, so it's x minus 5 squared equals y plus 4. It changes both those signs. And then to keep it in standard form, we usually see that in parentheses. My center, or my vertex, is 5, negative 4. And 4p is still in here. 4p would still be 1. P is 1/4. Because it's an x squared and a positive 4p, this is going to point up. So I go 1, 2, 3, 4, 5, 1, 2, 3, 4. And I draw my parabola facing upward. It's 4p up from here for the focus. So my x is 5, my y is negative 3 4/5. And then it's 1/4 down for the directrix, which would be y equals negative 4 1/4. What else you might see, and I think there's an example in tomorrow's notes, so if you get to it and you're completely lost on the web assign, just pause and we can do it tomorrow. But if you get to the part where, let's say this is like a 1/2 x minus 5 squared equals y plus 4, and I think there was something like this, not exactly like that, but on the on the PDF yesterday, you can't have anything in front of the parentheses. So I'd have to multiply both sides by 2 to get rid of it, and it'd be x minus 5 squared equals 2 y plus 4. Now my 4p is 2. So you can't have anything on the front of the squared term. You would want to get rid of it by multiplying or dividing by whatever's there to move it to the other side. And then also you'll see something like this. Let's say it says 4y plus 16. Let's say that's what my standard form gets me. I have to take this 4 off the y. There can't be anything attached there. So it would be x minus 5 squared equals 4 parentheses y plus 4. So you'd have to take that out. Now your 4p is 4. But there can't be anything attached to either variable on the front. You have to move it or take it out and leave it on the parentheses. And there can be nothing in front of the squared term. So be careful with stuff like that. Every single step, question, step 1 is get it into standard form using complete the square. And I put this on Canvas, like in the directions, it says you have to put it into standard form using complete the square. Then, based on what it is, if it's a parabola, you're going to identify the vertex, the focus, the directrix. If it's an ellipse, you have to identify the center, vertices, and covertices. And the foci. And if it's a hyperbola, It's the center, vertices, co-vertices, foci, and asymptotes. So I think there's only 5 questions on the homework, but you need all those parts for them. So just be really careful, make sure you're paying attention. And obviously, for most of that, you need a graph. That's how that's how the test would be. Depending on which of those it is, it could break it down. And it's not going to be 10 questions like that. It might be one, complete the square, then answer all the parts. It might be one, just complete the square, get it in a standard form. And then you might find one that just says, here's an ellipse, find the vertices. Here's an ellipse, find the foci. Like it's not going to be 10 questions where they're all like that. But yesterday's classwork assignment that had 8 questions, and some of you struggled on time. There's going to be more than 8 questions on your test. So you have to make sure that you're able to know the material well enough that the time does not kill you.
Could you see the number?
Mm-hmm.